Question 2a. Write out in full and determine the sum of the finite arithmetic series given there. Okay, the way to approach these is to start with a table. There's our value for r, and that's the value of what's in the bracket, so that's 2r minus 1. Okay, all we have to do is to substitute r into each one of those to get the values here. So there it is, and we can see immediately that the first term is 1, and the difference between any two terms is 2. 5 minus 9 is 2, 15 minus 13 is 2, and so on. So first term is a, common difference is 2. Now the sum to n terms of an arithmetic progression is n brackets 2a plus brackets n minus 1 close brackets d all over 2a, and n is 8, a is 1, and d is 2, so we'll put those values in, and that's what we get. We'll do a bit of cancelling there. That 8 can be cancelled with that 2, so we get a 4 there. 8 minus 1 is 7, so we can write 2 plus 14. 2 plus 14 is 16, times 4 is going to give us a value of 64. Now if you couldn't remember the equation and you were in an exam, the question has said write out in full, so it wants you to write all these terms. So in fact you could simply add all the numbers together. This is better obviously, but if you can't remember the equation, add those together. So 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9 is 25, plus 11 is 36, plus 13 is 49, plus 15 is 64, which is exactly what we've got there. And that's the answer to question 2a. Now, question 2b. Write out the first 5 terms and determine the sum of the infinite geometric series. So you can see it goes from 0 to infinity, and as before we're going to create a table. So the first value is 0, so the fifth value is actually 4, and what we're going to do is to put these numbers in place of that n there. Now any integer raised to the power of 0 is 1, so that gives us the first term, and then this is a fifth squared, a fifth cubed, and so on. So there we are, those are those values. Now looking at these numbers, you can see that the first term is 1 and the common ratio is a fifth. So we can write that down, and now we remember the equation for the sum to n terms of a geometric progression, which is a brackets 1 minus r to the n all over 1 minus r. Let's just think about this term for a second, because n is going to be infinity. Now if we look at these terms here, they're going down. So as n gets bigger, r to the n is getting smaller, and that's true for all numbers between 1 and minus 1. Outside of that range they actually get bigger, but in this case they get smaller, which means that as n goes to infinity, this term is going to go to 0. Okay, so as n goes to infinity, r to the n goes to 0, so we can write the equation and put the values in. So that's a, the first term, which is 1, and then it's 1 minus r to the n, but that's gone to 0 because n is infinity and r is a fifth, minus 1 minus over 1 minus r, which is 1 minus a fifth, which is 4 fifths obviously, and then we'll just invert the denominator to give us the answer, which is 5 over 4, and that's the answer for question 2b.